here. Now today our topic will be transistor sizing. Now, what is transistor sizing? Transistor sizing are the sizes of width and length, right? So in case of NAND gate, okay, let's draw a NAND gate first. This is PMOS, right? Okay. Now here, this is our A, this is our B, this is A, this is B. A, B, A, B. So now what? Now what will be the sizing? Now one is the sizes of NOT gate is this one. 2:1, 3:1, right? So let's write 2:1. This is 2, this is 1. 2:1 means if it is 8 micro, then it is what?
4.
4 micro. In our lab, we have seen this is 12 micro and this is 4 micro, right?
4 micro.
Yes.
So it is 3:1, right? Not
3:1.
Yeah. Now it can happen. So it will vary between 2 to 3. It can be 2, 2.2, 2.3, 2.4, 2.5, 2.8, up to 3. So it varies between 2 to 3, right? 2:1 or 3:1, something like that. Okay, let's consider 2:1. So if we consider 2:1, this is the ideal sizing of our NAND gate, not NAND gate actually, our NOT gate. So we will take this as our reference. Got my point? As our reference.
Okay.
So we want our every design to behave like this or perform like this, not behave, perform like this, because this is our reference circuit and the performance of this one is very tested. And I know that the performance of this circuit will be very good. So I want my every circuit to behave like this. So that's why I will be sizing according to this 2:1 ratio. Got my point?
2 to 1.
Now here, the sizing of this
Yeah.
there is a method called transistor sizing mathematics method. So we will be doing that. But before that, let's do some shortcut method. Okay. So I have drawn this using shortcut method. But if you do that using the mathematics or the full method, you will get the exact same result. Okay. Now here, I'm going to explain how I got this using shortcut method. Now here, this is your VDD, right?
Yes.
Hello. This is your VDD. This is your
Yes, sir.
output point.
Yes, sir.
This is your output point. How many paths, that means road, how many road do you have to go from here to here? You have to go from here to here. What are the
2 road.
One is A, right?
Yes.
Another one is
2 road.
B, right? Got my point?
Yes.
In
Yes.
these two paths, how many transistors do you have?
2.
That means one per path, right? Okay, let's think about
Yes.
this green path. How many transistors do you have?
1.
One, right? So
Yes.
your
Yes.
2 will be multiplied by 1. Since you have one transistor, that's why your 2 will be multiplied by 1. So 2 into 1 is how much?
2.
2. Now let's get back to this one. In the YOLO path, how many transistors do you have?
1.
1. So your 2 will be multiplied
1.
by 1 again. So how
2.
much? Got my point?
Yes.
Yes.
Okay. Now let's see next one. This color. And from this point to ground point, that means the inmost, how many paths do you have? How many roads do you have?
One road. One road.
One road only, right? This one.
Yes.
How many MOSFET do you have?
2.
So your 1 will be multiplied by 2. So 1 into 2 is equal to 2.
2.
Got my point? This one and this one both.
Yes, sir.
Because they are in same path. That's why. Got my point?
Yes, sir.
Yes, sir.
Okay. Now I'm going to do another example. Okay, for you. Another example. Okay. Then you will understand. Okay. Now we are going to design y is equal to AB plus C. AB plus
D.
C. Okay. AB plus C. So what is AB?
Multiplication.
Serious. Sir.
N must serious and B must parallel.
AB plus C. This is your A, this is your B. So now here you have to now here this is your A, this is your B,
It's B.
this is your C, right?
C. Yes.
Now this one is
And B. C.
A, C, right? So oh, by the way, you have a bar. So how to do the sizing? Now first of all, let's think about this one. So how many paths do you have from this point to this point? That means the VDD to output point. This is your output point, right?
Yes.
How many paths do you have? How many road do you have to go from here to here?
2 road.
2 road. How?
3.
4.
One is A and C, right? Like this. Okay. Another one. Yasin.
B. C.
From B.
BC.
With C.
Exactly. Exactly. Right.
Yes.
Now think
Yes,
about this
sir.
one. At first, think about this one. Let's use the green color. Okay. How many MOSFET do you have in the green road?
2.
2. So your 2 will be multiplied by 2.
4.
2 into 2 is equal to how much? 4, right? So this sizing will be
Yes, sir.
4. This sizing will be 4. Both of them will be 4 because both of them are in the green road, right? Okay.
Yes, sir.
Now consider the orange one. That means the yellow one. How many MOSFET do you have?
1.
No. This one and this one also.
2. C. C.
2, right?
B. C. 2.
BC.
Yes.
So 2.
Yes.
So your 2 will be multiplied by 2 again. Right? 2 into 2.
4.
4, right? So this one will be 4.
Yes, sir.
Then this one will be 4 as well. Now, since both of them are 4, in the both calculation, we got 4, right? In both calculation, we got
Yes.
4, right? So no deviation. So
Yes.
this is
Yes.
all right. This is correct. We can write 4. Got my point? In both calculation, both of them were 4, right? So we can use 4. Got my point or not? Yasin?
If same, if same, we take 1.
No. If it is same, we will take 1. If it is not same, that time we will have some trouble. We will discuss that later, not now.
Okay.
If it is same, it is same.
Okay,
Obviously,
sir.
right? Okay, look like this. Okay,
Yes,
think
sir.
about this. Hassan,
Yes, sir.
you have 2 friends like Yasin and Saeed. I asked Saeed,
Yes, sir.
what is Hassan's weight? Saeed said Hassan's weight is 50 kg, right? And
Yes, sir.
I
Yes, sir.
asked Yasin the same question. Yasin said his weight is 70 kg. So which one I will believe? So that time I need to verify, right? That time I need to
Yes,
verify.
sir.
But if both of them said his weight is 60, his weight is 60. That time I will definitely believe it, right? Got my point?
Yes, sir.
So that's why
Yes,
if
sir.
Yes.
both of them are 4, I will take 4. If both of them are not same, that time I need to use mathematical calculation to measure it. Okay, I do not believe both
Okay.
of you. I have to measure it by myself. Okay, like that. Now here,
Okay, sir.
now come here. So how many road or path do you have from this point to this point?
AB.
Yes, AB one
Four.
road, right? Another
Yeah.
one,
Yes, sir.
another one,
Another C.
C.
only C, right? So think about the pink one.
Yes, sir.
So how many MOSFET do you have?
2.
2. So your 1 will be multiplied by 2. So 1 into 2.
2.
So it will
2.
be 2, right? So this will be 2.
Yeah.
This will be 2.
2.
Now think about the purple color. So how many MOSFET do you have in the purple color?
One.
1.
1. So your 1 will be multiplied by 1 only.
1.
Okay? This is the sizing. Understood?
Sir,
Yes, sir.
that one repeat, sir.
Okay, no. I'm not going to repeat. I'm going to give you one example. Then I will do it again. Okay?
Okay.
Okay.
I'm going to give you one example. Do the example. Then we will do that again. Okay, you do it.
Okay, sir. Okay, sir.
Okay. I'm going to give you I'm going to give you 5 minutes of time so that you can do it. Okay. Now here, A plus BC plus D. All of you design it. Oh, you have a part. All of you design it and do the sizing. Okay. Take 5 minutes of time. I'm going to pause the recording. Take 5 minutes. Okay. This is the sizing of this one. Okay.
Sir, well, I have one question.
Yeah. What is the question?
You see in B, BMOS,
Yeah.
B,
Yeah. In the PMOS.
but they are sharing this 2 ways.
Yeah. They are sharing. This one
Sharing.
6, right?
Yeah. So sharing is good.
They are sharing, but their size, if we consider the both path, their sizing is same, right?
Yes, it's
So,
6.
so no problem in sharing.
Okay, sir.
Okay.
Sir, and I have one question, sir.
Okay. Which one?
And sir.
Yeah.
Hello.
Yeah.
Sir, I designed it and different design, but can I show you my design?
Okay. You can show me your design.
Okay.
I'm going to stop the share.
Okay.
Where is your design?
Sir, 1 minute. Can you see my screen?
Okay. No,
Sir, this is my design, sir.
no, your design is wrong. The upper one is correct, but the lower one is not correct, right?
The lower,
It's not
this one
correct.
is correct.
Yeah, this one is correct. Okay.
Okay, sir. Thank you. Okay, sir.
Okay. You can stop the sharing. Okay. Now I'm going to give you another example. That time you will face some problem somewhere, either in NMOS or in PMOS. Okay. You will face problem in anywhere. You can face problem in both of the sides. You can face problem only on NMOS. You can face problem only on PMOS, right? That time you have to use the mathematical analysis. Otherwise, you will not be able to solve it. Okay, I'm going to erase everything. Now here, I'm going to give you the example. Y is equal to A everyone design it and try to, okay, you have a bar. Try to size it. Okay? Okay, no.
Okay, sir.
Let's design it. Okay, let's design it together.
Okay, sir.
Let's design it together. A. So you have a A, right?
Yes.
Now then you have what?
B.
You have B. This is your B. Then you have C. Then you have D, right? Okay.
Yes, sir.
This is your B. This is your C. This is your D. This is your
E.
E. Now on the top you have A will be in series. This is your A. Then you have what?
B.
B parallel. C and D, they are series. They are parallel, so they will be in series. This is C and DE. This is D. This is E. Okay. A. This is the question that might come in your exam. This sort of question. Okay, you will face problem. That type of question will come in your exam. I will not give AND get, NAND get, something like that. Okay, and this is your Y.
Okay.
So what will be your sizing? Think it. See this. So let's use the green color. From this point to this point, how many paths do you have?
A. B. A. B.
A, B. So one path. Okay, I'm going to write it. Okay, I'm going to write it for PMOS. First PMOS. At first, we will consider PMOS. So you have one path that is AB. Okay. Next one.
ACD.
Next one is use
A.
color.
ACD.
A, C, D. Right. Okay. Let's
Yes.
write it. ACD. Okay. Next one.
ACE.
Let's use the yellow color. No. Let's use this color. This one, right?
Yes, sir.
ACE. A,
C.
C, E. Okay. Now
Okay.
think about this. So if I consider the AB, so how many MOSFET do you have?
2.
2. So what will be your sizing?
2
2
times
into
2.
2. That means
4.
4
4.
and
4.
4. Okay.
Okay.
Okay. Now think about the orange one. How many MOSFET
3.
do you have? 3.
3.
So 2 times 3. That means 6.
6.
This will be 6. This will be 6. This will be 6. Right?
Yes, sir.
See this one here. You got a problem, right?
Yes, sir. Different.
Different time. So which one will be the sizing? If I ask Hafiz, what is your height? Can you tell me your height is 5 feet 4 and 5 feet 6?
No.
No, because height cannot be different, right? Height is
Yes,
a
yes, sir.
definite. Height is a definite. What is that? Height is a definite point. That is a definition, right? That has a definition.
Yes.
That is a definite number. So here the sizing should be definite number. Either it is 4 or 6 or something else. So we got a problem, right?
Yes,
So
sir.
we have to solve the PMOS using what? Using mathematics. Okay.
Okay.
Now, before doing the mathematics, okay, let's erase everything because we are having problems. So I'm going to erase and we will find the problem. Okay, first of all, I'm going to erase this, not needed. First of all, this is our path number 1. This is our path number 2. This is our
Number 3.
3. So which one is the bigger path? ACD and
ACD.
ACE. So we will calculate for bigger path first. Why? Because the bigger path means we will have more values at a time. Okay? We
Yes,
do
sir.
not solve for smaller path first. Remember, we will solve for bigger path first. Why? Because they are, what should I say? What is the I know the Bangla word. I do not know the English word.
Bangala, sir.
No. Shankha Goristo. Do you know Shankha Goristo? That means they are bigger in number. Okay? Okay. Think about this. You have 5 brothers, right?
Yes.
All of you are 5. So you have 4 brothers. So your father has 5 sons. So 2 of them are telling one thing. 3 of them are telling another thing. Okay?
Yes, sir.
Yes.
So both of the group are right. Both of the group are right. So as a father, your father is saying that both of the group are right, but one group that has 2 sons, another group that has 3 sons.
3.
Where your father will go?
Pass
3 was.
3. Pass 3.
3, right?
Yes,
Your
sir.
father will take the side of 3 and try to convince the other 2.
Yes, sir.
Consider
Okay?
majority.
So this is how you will calculate. So you will go to the side of 3, then you convince the other 2. So that's why we will do the sizing for bigger path first. So here we have ACD and ACE. So either one is fine. If you calculate for ACD, you can use the same value for ACE as well, because they are actually same path, right?
Yes, sir.
Then you go for the calculation for AB.
AB.
Understood my point?
Yes, sir.
Okay.
Yes,
So at first, which one you want to do, ACD or ACE?
LCD, sir.
ACD. Okay. ACD we want to do. So your formula will be this one. This is your formula. 1 divided by beta. Since it is PMOS, I'm going to write P equal to 1 divided by beta P plus 1 divided by beta P plus 1 divided by beta P. Now this one is the reference. That means the not get reference. This one is for not get. This one is for A. This one is for C. This one is for D. Understood my point?
Yes, sir.
This is the formula. This formula is exactly like your resistor in parallel, right? Remember resistor in parallel? 1 divided by R is equal to 1 divided by R1, R2, R3. Remember?
Yeah, yes, I remember.
Now here I'm going to write them. Okay, by the way, what is beta P? Beta P will be like this: mu COX WP by LP, right? From where we got this formula? From IDS equation, remember? Hello?
Yes, sir.
Hello, sir.
IDS equation. Now mu and COX, they are actually common, they are actually constant, so we can actually ignore them. So what is your beta P? W by L, right? W by L.
L.
Okay. So we are going to write W by L here. So beta P is equal to W by L, 1 divided by W by L equal to 1 divided by W by L, 1 divided by W by L, 1 divided by W by L. And for this one, this is the reference, right?
Yes, sir.
So I can call it reference. You can call it reference, R. You can call it R with a bracket. Do not give a circle. You give a bracket. You can write this is our
Reference.
R. That means reference. This one is what? This one is for A. This one is
C.
for C. Which C? This C. This one is for
D.
D. Okay. Now here reference is 2:1. Remember
Yes, sir.
what 2? This is WP. This is WN.
L.
No. This is WP. That means the P MOSFET. That
B
means
must
the
be
not get.
M, sir.
And what is the L for this one? L is 1. Always 1. L is always 1. So your WP was 2. Your LP was what?
1.
1. Because we keep our L fixed. That's why not needed. So your WN is 1. Your LN is what?
1.
Also 1. Got my point?
Yes, sir.
Remember, this is for not get. W is equal to 2. L is equal to 1. W is equal to 1. L is equal to 1. Okay? Always remember. So 2 and 1, right?
Yes, sir.
So these 2 and this 1. So we'll be using this value. So what I'm going to do, I'm going to change. See, this L will go up. This L will go up, right? Because this is 1. This L will go up. This L will go up. This L will go up. Understand? Okay?
Okay, sir.
Understand? This is an algebraic expression. This L will go up. L will go
Yes,
up.
sir.
So I'm going to erase this and I'm going to write L. Erase this, erase this, erase this. And I'm going to write L, 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 L. Right? Now,
Yes.
the value of L will be what?
1.
1. So can I, what is that? Can I change the value to 1?
Yes, sir.
So I'm going to change the value to 1. Okay? What is the value of W for reference? For PMOS?
B must 2.
2. This is for PMOS, right? So I'm going to write 2 here. Okay? Then this WP for A, WP for C, WP for D, they are in same path, right? They are in same path. So their value will be equal as well. Their value will be
Equal, sir.
equal as well. So this is equal, this is equal, this is equal. So can I write 3 divided by WP? Because they are same, right? So 1 plus 1 plus 1. Can I write 3 divided by WP?
Okay.
Because they are same,
Yes,
right?
sir.
So I can write 3 divided by WP, and I can write, I can bring the C here. No. And I can bring the D here. I can call it ACD. This is for same path. Now here only the unknown thing is what? Unknown thing? WP, right? So I'm going to erase these. I do not need it. So can I multiply cross? WP will be multiplied by 1, 2 will be multiplied by 3. Can I do that?
Okay.
So your WP will be what? 2 into 3, that is 6. Understood? Hello? Understood?
Yes, sir.
Okay. Now I'm going to write the sizing. So A is 6 because we got ACD. C is also 6. D is also 6. Understand?
Yes, sir.
Now if we see your ACD and ACE both are same path or the same size path. Size means what? That means you have 3 MOSFET, 3 MOSFET. Same sizing. So this will be 6, 6, 6 as well. So A will be
Yes,
6,
sir.
C will be 6, and E will be 6 as well, right?
Yes, sir.
Since A is already found out, so we can ignore it. C is already found out, we can ignore it because both of them are same. So A, C, D, A, C, E, they are 6, 6, 6. Okay, remember I told you some shortcut method. Okay, since they are same, so we can cancel out. This is the method. This is the actual method by which you can get 6, right? You know it already. Now this is where your calculation will be needed. Where A and B. Now do for the smaller path. Now write like this. Always write like this for for AB. Okay, write like this for AB. Understood? Then what will be a calculation? Do not need it. Do not need it. A and B needed, right? Okay.
Yes.
So 1 divided by beta P reference equal to 1 divided by beta P A for this one, and 1 divided by beta P B, right?
Yes, sir.
This is the formula. Now again, you have to make it 1 divided by what? W by L.
WL.
This is for reference. 1 divided by W by L. This is for A.
A.
1 divided by W by L.
D.
This is for B. Remember, they are all P MOSFET, right? So you can write LP, WP. Okay. Now here, look at this. This L will go up. Can I write? This L
Yes,
will
sir.
go up. This L will go up. So I'm going to write L, L, and L. And both of them, all of them are 1, right?
Yes, sir.
Can I ignore them?
Okay.
Now, what is the value of reference? 2, right?
2, sir.
Okay, 2. What is the value of A? We already found out. What is that?
6.
6. Can I write 6?
Yes, sir.
Okay, I'm going to write 6. The only unknown is which one?
B.
Unknown is B, right? So can I take these and can I take it there? 1 minus 2 divided minus 1 minus 6.
1 over 6.
WP. This is for B, right? Remember, this is for B. So from here, we can find out what? This
Oh.
is 6. This will be 3 minus 1. WP. This is for B. So how much we are getting? This will be 2. This will be 3, right? 6, right?
Yes.
So can I make it 2?
Gonna be 3, sir.
Okay, 3, right? This will be 3. So you want me? Okay, wait a second. Okay, can I multiply cross? So this one, okay, we can actually rotate them or inverse them, right? So your WP will go there, your 6 will go there, and your 2 will be there. So your final WP value will be what? How much? 3.
sir.
So can I write 3 here? So this is the answer. Before, using the shortcut method, this was supposed to be 4, right? This was supposed to be 4. Understood?
Yes, sir. 2 times 2 times 2.
Yeah, it was supposed to be 4, but now it is 3. Why? Because we adjusted that. We adjusted. Okay?
Okay, sir.
Understood, everyone?
Yes, sir. Yes.
Hafiz?
Yes, sir, already.
Okay, Yasin? Hello?
Yes, sir. Yes, sir.
Saeed?
Sir, yes.
Stop, sir. Stop. We understood.
Sir, can you repeat one more time? SCD, SCD.
Oh, SCD, right?
Yeah, SCD, yeah.
Okay. For SCD. For A, C, and D. So your formula will be 1 divided by beta P reference, 1 divided by beta P A, 1 divided by beta P C, plus 1
P.
divided by beta P D, right? SCD. Here, all of them will be same because all of them are in the same path, right? We'll consider all of them are same. So can I, okay, by the way, this one will be what? 1 divided by W by L. This is for PMOS and this is for reference. This one will be what?
Uh,
For A, right? And I can write like that. This is the next one will be C, next one will be for what? D. This is for reference. This is for A, B, A, C, and D. Now, since L is value equal to 1, L value 1, so I can what? I can ignore them, right?
yes, sir.
And what is the reference value of WP? Is 2. Can I write 2?
Yes, sir.
Of course, I can write 2. Then WP, 1 divided by WP, 1 divided by WP, all will be for A, C, and D. I can consider them equal and I can write 3. Right? I can write 3, right? How?
Yes, sir.
How can I write that? A equal to A equal to A. Can I write 3A?
Yes, sir. Yes, sir.
Oh, like that. So I can write 3. This is how you can get the value of WP. This WP is equal for A, equal for C, equal for D. Okay?
Yes, sir.
Now, go to the NMOS. Now go to the NMOS, everyone. Look at how many paths you have. From this point to this point, how many paths you have?
A,
A, 1 path. So I can write A. Next.
BC, BC,
B, sir.
BC,
B,
PC.
C. I can write BC.
BDE,
Next.
BDE,
Okay. B, DE, right?
yes, sir.
Now I can write BDE. Now here, which one is the biggest path?
BDE.
So we will do the sizing for BDE first. Okay?
Okay, sir.
So the sizing will be 3, 3, 3. B will be 3, D will be 3, E will be 3. So I am going to write 3, 3, and 3. Right?
Yes, sir.
Then BC. Sizing will be BC. For BC, the sizing will be what? The sizing will be normally. Using the shortcut method, it was supposed to be 2 and 2, right? But see, 3 and 2, they are different, right? It cannot happen. It cannot happen. So you have a problem there. Using that since that problem is there, you have to use the mathematical calculation. And for A you do not need any calculation because A is A. You can see it is only 1. It is not conflicting with any other. The value will be 1. It is not conflicting with any other. Okay. So this one you do not have to do the calculation. But for BC and BDE, you have to do what? Calculation. So at first, which calculation you will do first? BC or BDE? BDE.
Yes, yes,
Then
sir.
you will do the BC. Okay?
Yes, sir.
So this is a question that might come in your exam, or this sort of question. Okay, I might give you some different example. That time you will have some. Here you have problem in both cases, PMOS and NMOS, both sides you have problem. Got my point?
Yes, sir.
By the way, what will be your final answer? What will be your final answer? Do you know? This will be your final answer. No. This is your final answer. Maybe this one will be 1.5. I forgot. Maybe this one will be 1.5. So this diagram will be your final answer. A6, B3, C2, D36, E6, like that. Okay. By the way, here we use 2:1, right? 2:1 ratio, right?
Yes, sir.
Like this. Here we put 2. If I use 3:1, then the calculation will be different, right?
Yes, sir.
Remember, the calculation will be different. So ask for it. If I give the ratio, then fine, use that. It can be 2, it can be 2.5, it can be 3. If I do not give you the ratio, use 2:1. Okay?
Okay, sir.
If I do not give you the default ratio, use 2:1. Understood, my dear?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Wait a second. I think our class is done. I'm taking screenshot. So I hope you understand it